to prove that triangles are congruent. And these were the 5, okay? So if you want to use SSS, you want to use that SSS, that means side, side, side theorem, you need to prove that the 3 pairs are congruent. So if we have triangle A, B, C, D, E, F, you need to show that this side, the 3 sets, it has 3 sets of congruent sides. That's 1 set, 2 sets, and 3 sets. That means you need to prove that all the 3 sides are congruent to use SSS. For the following, for the next one, you need to know that the order matters. The order matters. Okay, so in here, it says SAS. It means it has to have 2 pair of congruent sides and 1 pair of congruent angle. And that congruent angle needs to be in the middle because the order matters. So if you have triangle A, B, C, D, E, F, in here, if I'm going to say like, okay, side BC, this side, and side EF, those 2 sides are congruent. And then I have like, oh, side AC is congruent to side BF. I'm able to prove that those 2 side congruent sides are congruent. Then for me to use SAS, the congruent angle needs to be in the middle. So if I were to say, oh, these 2 angles are congruent to each other, then you cannot prove that these 2 angles are congruent by SAS because the pair is not in the middle, right? So both of the congruent angles both of them need to be in the middle of the 2 congruent sides, just like in this case. So that's 1. And then we have ASA. In this case, we need 2 pairs of congruent angles and 1 pair of congruent sides. So let's name these triangles ABC, DE, F. So in this one, I'm going to say that angle A is congruent to angle D. I was able to prove that those 2 angles are congruent. And I was able to prove that angle C is congruent to angle F. I was able to prove that. Then you're like, okay, I have 2 congruent angles. Yes, I have 2 perfect congruent angles, but I need 1 congruent side. And the congruent side needs to be in the middle because that's in the name. So for me to show, if you were to say, these sides are congruent, well, no, because the triangles are here, the congruent angles are here, and the side that's in the middle needs to be there. So that's the side that needs to be congruent for both of them. Both of them need to look like that. It needs to see that you need to see that the 2 paired angles are there, and then that side is in the middle of those 2 congruent angles. That is for ASA. Now we have AAS. So in here, we still need 2 congruent angles. So I'm going to name these triangles like this, like we have been doing. And for the sake of the example, I'm going to say that angle A is still congruent to angle D, and angle C is congruent to angle F. For S, yes, we have 2 pairs of congruent angles, but the S cannot be, the congruent side cannot be this one because that will be ASA. And here, the congruent side can be this one right here, angle, side, that means 2 congruent angles, or the congruent side can also be this one right here because we have angle, side. So if we're able to prove that those 2 options, I just need to see the difference. Here, to use ASA, the congruent side is in the middle, but in AAS, the congruent side is at the end. And remember, it can also be this one right here, okay? So for the last one, we have HL. This is the one that you can only use on right triangles. Only. You can only use it on right triangles. Okay, you can only use that right triangles. So in here, the hypotenuse, so the hypotenuse, that means the side across that 90-degree. You see how we're pointing at the sides? Those sides are pointing. Those are your hypotenuse. So those need to be congruent. They need to. And then the same leg needs to be congruent. If different legs are congruent, then you cannot use HL. Okay, so hopefully we went over what you didn't understand on how to prove that triangles are congruent. These are the only 5 ways. And then we also talk about the CPCTC. That means the corresponding parts of congruent triangles are congruent. What does that mean? Well, remember, if we were able to prove that triangles are congruent, then we made this, the congruency statement. and the parts, the angles and the sides are in the same spot, in the same position, are congruent. So A is in the same spot as D, so therefore they're congruent because the triangles are congruent. And in angle B, that is in the same spot of angle E on the other one, since they're corresponding and the triangles are congruent, that means that those angles are congruent. And in here we have angle C and it's congruent to angle F because they're in the same spot. So that means that angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F because they're corresponding. So in here, again, A congruent to D, B congruent to E, C congruent to F. They're congruent because they're in the same spot. And not only angles, corresponding angles are congruent, but also the corresponding sides. So we have side AB congruent to side DE. And then we have side BC congruent to side EF. And then we have side AC congruent to side DF. So that means that side AB is congruent to this one. Side BC is congruent to this one. And side AC congruent to this one. So in the same spot. So remember, CPCTC stands for corresponding parts of congruent triangles are congruent. Okay, so when am I going to use CPCTC? When am I going to use it? When we're being asked to prove that parts, what are parts? Well, what are triangles made of? Of sides and angles. So when they're asking us to prove that sides or angles are congruent, then that's when we need to use CPC. We use it when they're asking us if what sides or angles are congruent. So CPC is when we're asking to prove sides or angles are congruent. But first, you must prove that the triangles are congruent. Okay? So first we need to prove that the triangles are congruent. What do you mean? Well, first you need to prove that the triangles are congruent, but hey, how do we prove that the two triangles are congruent? How do we prove if two triangles are congruent? What do we use? Okay, how do we prove that triangles are congruent? Well, we prove that two triangles are congruent by using the SSS, the SAS, the ASA, the AAS, or the HL theorems. So first we need to prove that the triangles are congruent by using these five. And then if we prove that these two triangles are congruent by using one of these five, then we can use CPCT to prove that sides or angles are congruent. And let me give you an example, okay? So an example we have here, we're going to do what you've been doing all this time. First, we're going to identify congruent sides or angles given the information. So in here you say, given that HI, side HI is congruent to GJ. So GI, we know that side HI is congruent to side GJ. Okay, so they're telling us that this side, HI right here, is congruent to GJ. How do we know those two sides were congruent? Because it was given to us. It was in the given information. And then they say that angle GJH and angle IHJ are congruent. So now angle GJH is congruent to angle IHJ. So they're telling us that this angle GJH, this one right here, is congruent to this angle right here, IHJ. to this one right here. They're telling us that those two angles are congruent. How do we know? Because it was in the given information. That's how we know. And then you have to step back and remember, you're going to now look at the picture and be like, okay, do I see any vertical angles? Do I see these type of angles in that drawing? Do you see them? No, so we can identify it. But what can we see? We can identify reflexive property. Remember, reflexive property is when two triangles are sharing a side. Well, we have one triangle here. We have another triangle right there. They're sharing this side, so that's called reflexive property. What is the side that they're sharing? They're sharing side HJ is congruent to HJ, and that's reflexive property. That's reflexive property because those two triangles are sharing that side, that wall, remember? Then after we have that, then we have to say, okay, first we need to prove that the triangles are congruent. Why? Because look, they're not asking us to prove that the triangles are congruent. They're asking us to prove that angles, the specific angles are congruent. And when they're asking you to prove the specific angles are congruent, remember, we're going to use CPC. When they're asking us to prove that sides or angles are congruent, then we need to use CPC. TC. But remember, before you use this, you first need to prove that the triangles themselves are congruent. So first we need to prove that the triangle GJH is congruent to triangle, remember the annotation triangle, IJH. First, I need to prove that those two triangles are congruent. Remember, how do you prove the triangles are congruent? By using these 5. These are the only 5 ways that you're able to prove the triangles are congruent. These are the only 5. And remember, are these right triangles? No, you don't see the 90 degrees, so these are not right triangles, so automatically HL is out. And SSS, look at the thing, don't add anything. That was the only sides that we were able to prove that they're congruent, the only angles we were able to prove that they're congruent. We cannot use SSS because we did not prove that all 3 sides were congruent. Since we were not able to prove that all 3 sides were congruent, we cannot use SSS. However, can we use SAS? Well, were we able to prove that 2 sets of sides are congruent? Yes, 1, 2. We were able to prove that 2 sets of sides were congruent. And we need 1 set of angles. Yeah, we were able to prove that 1 set of angles were congruent to each other. But most important, are those angles congruent in the middle of the 2 congruent sides? Yes, they are. So yes, we are able to use SAS theorem to prove that these 2 triangles are congruent. Now that we were able to prove that these triangles are congruent, now we can prove that corresponding angles, which is GHJ, is congruent to this other corresponding angle, which is IJH. These angles are corresponding of these 2 congruent triangles. So the reason is CPCTC. Okay, so now you're going to finish your independent practice.